All right, so for this section, we're going to be talking about quadrilaterals inside of circles. So we have something called the inscribed quadrilateral theorem. And inscribed, remember, means inside of a circle. So if we have a quadrilateral inside of a circle, then opposite angles of that inscribed quadrilateral in a circle are supplementary, which means they add up to 180. It's a little bit of a different concept from what we've learned about quadrilaterals before. So they're saying if I have a quadrilateral inside of the circle, then opposite angles, so an angle over here, an angle over here, for instance, so B and D, those are going to add up to 180 degrees. And the same thing over here if I have A and I have C. So let me actually highlight those a little bit. So B and D add up to 180 degrees. And then same thing with A and C. A and C would add up to 180 degrees as well. So we're just going to be using that theorem throughout this lesson today. First one says, in the diagram, quadrilateral math is inscribed in the circle with the measure of arc AT 50 degrees and the measure of arc TH is 170 degrees. How can you find the measure of angle T? So angle T is talking about this angle over here. Now we're talking about arc, so we're probably going to be talking about an arc in relation to this. So let's see what arc it opens up to. It opens up here and it opens up over here. Now I want to figure out what this measure of the arc is. And I know circles all equal 360 degrees. Well, I'm not using 50 degrees, so I'm going to subtract that, and I'm not going to be using the 170. So I'm going to do 360 minus 50 minus 170. So that's going to be, calculator, so 360 minus 50 minus 170, so that's going to be 140 degrees. So that means I got 140 degrees here. So I got 140 here, and then this inscribed angle is going to be half of the 140. So that means I get 70 degrees. So that's going to be 70 degrees right there. Now for the next one, I'm going to have quadrilateral ABCD is inscribed in circle O. So let's go ahead and draw this out. So I got A, B, C, D is inscribed in circle O. Angle B is 4y plus 27. Angle D is y minus 12. Determine angle D. So I know that B and D are going to be supplementary to each other. So B plus D is going to equal 180 degrees. So we're going to have 4y plus 27 plus y minus 12 equals 180 degrees. Combine my like terms. So I got 4y and a y right here. So that's going to be 5y. And then 27 minus 12 is going to be 15 equals 180. From there, we can minus my 15. I get 5y equals 165. And then divide by 5. So 165 divided by 5 is going to be 33, but let's double check. So 165 divided by 5 is going to be 33. So y equals 33. Now, they didn't ask us to solve for y though. They asked us to find angle D. So all I have to do is take angle D and plug in my y. So 33 minus 12, and that's just going to be 21 degrees. And that'll be our answer.